Thank you for joining us. I'm Harpreet, co-CEO, co-founder at Launchable, and we'll talk about sort of how to eliminate sort of these test cycles and slash test run times. Right? So the agenda today is about we'll set context on the problem that's happening with development teams today. And we'll talk about how Launchable actually comes in and solves for that. And then we'll sort of do a technology deep dive. I think that's really where most people want to see, like what's actually happening behind the scenes. And finally, we'll talk about a case study on how we've helped, right? This whole session should take about maybe 40 minutes. My hope is to actually show you how easy it is, that how we've been able to achieve like a push button machine learning to sort of slash dev cycles. But I also want to sort of peel the onion and show what happens behind the scenes, so you walk away with an understanding like how does actually machine learning help in this world, and like why this approach makes sense, right? We've just opened a Discord channel, so it's on Launchable Inc./community. So if you want to hang out with us during the session, after the session, just go to Launchable Inc./community. We have a channel there called Spacebar, and so you can join Spacebar to have some virtual drinks with us, right? So let's just get in, right? So getting into the context, we started the company because we've sort of been developers, and we faced this problem ourselves. And not only that, we've seen a number of people ask this, right? You're trying to push some changes in, and then you have to run through all the tests, and the question comes in why, right? I just made a doc change. Why do I need to run the entire test suite? Or I have like a very small time window to push changes in, and instead of testing the relevant changes, I'm now like stuck with testing the whole harness, right? Now the other side of it, if you just go one level up in the management chain, right, it's all about agility, right? Management wants to run fast. We as engineering managers are trying to deliver things fast. There's been a tremendous pressure to deliver fast, and so on and so forth. And how do we deliver fast is like the constant question that comes in. And lately there's been this mantra that move fast, break things, and people have been embracing that. What tends to happen when you move fast and break things is the quality of your software actually goes down, right? And customers are running away. I was just talking to somebody well known in the industry maybe a month and a half, two back, and they were talking about how churn is one of the biggest afflictions that are hurting SaaS companies, right? And from their point, it was like no point working on sales and marketing and getting them to walk through the door if the quality isn't good enough and people walk away, right? So as engineering managers, we're struggling with this. If you sort of think about engineering directors and VP of engineering, they're trying to build this rocket factory that consistently delivers goods at really high quality. And agility and high quality don't quite mesh together, right? And so building that rocket factory is really hard. And in the last half a dozen years, people have moved to DevOps, right? That seems to be the panacea that's helping people. It's all about continuous improvement, continuous delivery, continuous deployment, and getting things out through these continuous improvement process, right? One of the challenges that I've sort of personally faced, and I've had numerous companies through it, is when you walk on this DevOps transformation route, it takes months, if not years, of these changes to go in before you can start seeing like reasonable impact, right? And even when you start off with these continuous improvements, you sort of orchestrated your pipeline, and the first thing that happens is the test sort of become the stumbling block, right? the test becomes a stumbling block because in a lot of these organizations, they're almost because quality is sort of thought as an afterthought, or perhaps you haven't automated things, or you have automation is fairly nascent. Um, in various parts of their development life cycle. It might be owned by different teams. You almost have this waterfall approach on testing, right? Your integration test might not be completely might be owned by somebody else, and the feedback coming in from there is not coming in fast enough. So it essentially breaks this continuous nature right at the gate, right? And that's one of the key reasons why people don't quite realize this infinity loop of DevOps. Right? So the question becomes what next, right? Clearly, sort of getting tests out is not an option. I was reading this Gartner paper where it said like every organization thinks of tests as the biggest control for DevOps, right? And by that, what I mean is it's effectively the gate that controls and ensures that your customers are not getting a bad experience with tests, right? So in that worldview, as where teams are headed towards is to sort of make quality much more continuous, right? And the same paper talked about 75% of the organizations are going to have continuous quality approaches by 2023. I think that is fairly optimistic because we've been asking these questions to folks in the last year on what are the challenges that they're facing with testing today. And I'll throw this to you guys and girls who are on the call is like, think about what are the key challenges you're facing with testing as you go through this presentation, right? So one of the key ones that we've seen is this notion that tests slow us down, right? And it's almost like rest of the world is watching like a few unicorn Silicon Valley companies who are really driving things continuously and fast, and everybody is desperately trying to follow through in the hope of getting to that promised land, right? You have like pipeline upgrades, you have code changes, you may be re-implementing to get to the container-based architecture just so that you can deliver fast. And when you sort of peel that onion further, these are the 4 or 5 key challenges that we are hearing our customers talk about. Right? So it's slow test feedback. There's this notion of flakiness of tests. The developers have lost trust with their tests because the tests are unreliable. QA teams are trying to figure out like what tests should they run based on the changes that dev teams have made it. If things go wrong in a bigger team, you're trying to figure out like who actually broke the stuff and how can we actually fix this further, right? Fast. And then on the sort of management side of the house, it's the notion that the infrastructure costs are very high with QA. Right? And by that, what I mean is you could spin up multiple things on the cloud to test things faster, but ultimately you're writing the check to Amazon there, right? And these are sort of the problems that we think of as our North Star that we are headed towards. So let's just talk about what Launchable is doing and how we are what we are specifically doing in the space. So Launchable started by me and Kosuke. We've been in the Jenkins world for a while. He's created Jenkins. I built a business around Jenkins. And so we've helped organizations go through these DevOps transformations. And where we are taking Launchable is we think we can make continuous quality happen, right? That waterfall approach, the slide that I was talking about, we want to kind of get rid of that and make quality much more continuous, right? And to that end, where we are honing in on is this notion of the slow feedback that are killing teams, right? And the way to think about these very simply are like 2 sets of use cases, right? One might be on the pre-merge side or like unit test cycles, where long tests in this worldview might just be 30 to 60-minute tests, right? Or less than that. right? But you're running them so often that every iteration of this test actually adds up, right? And then there's this notion of long, integration tests or smoke tests or post-merge tests, where a number of components are being built together. They might be monoliths applications, they might be microservices applications, but it takes a very long time to kind of, get things running. So if you are a development team, you're sitting there, or you're a developer, you're sitting there, you push changes in, you might be in the unit test cycle, and you're not getting the feedback fast enough, so you can't make progress. And finally, you made some progress and you push some changes in, and you have some heavy sort of integration tests that are running, and you come in tomorrow morning, only to see the nightly report that made broke things last night, right? Pretty bad way to start the day. But that's sort of what most people spend time on, right? So how can we shrink that feedback time? How can we shrink that dev cycle time? How can we shrink that testing time? Is really where we honed in, right? And so how we do it is the key sort of intuition here is we think of, like, if you think of what tests are in your test harness or environment, right? And you're trying to figure out what tests to run based on the changes that are coming in. It's almost like finding a needle in the haystack, right? And we are really good at finding that needle in the haystack. And we do so by looking at the changes that are coming in. And we have a underlying machine learning algorithm that actually figures this out and says, like, okay, change X has come in. It implies that we need to run test Y, right? And we can really hone in to that level of detail. Now, that's hopefully gives you an intuitive picture of what we are doing. This talk itself was sort of was about how to do it. So I'll just get into how we do it. And to be honest, is just one slide in this entire presentation. And the way we've done this is we have built a CLI that actually integrates into your build processes, right? And once you integrate this into your build process, and this lays out the steps towards that, right? So what it's saying is, you start the build. Before you start the build, sort of call Launchable and tell us, sort of give us a Git snapshot of what are the changes that have happened in your system. Once you've recorded this, you can continue running your build. You just build the stuff. And then when you're about to start testing, right, call Launchable and say, hey, Launchable, I'm about to sort of start a new test session. Give me a set of tests that I should be running. And Launchable comes back with a subset. And that subset can range from 0 to 100%. And your test runner can then continue executing that test run. And once all the tests are run, you tell Launchable, hey, based on what you told me, I ran these tests and here's the results that I got. And those results are recorded by Launchable. And we use that to continue training our machine learning model, right? So very simply, it's really about 4 or 5 lines of integration into your build scripts, right? So it comes in very easy. It goes to our sort of philosophy and the point I was making earlier, that it takes months for people to realize DevOps transformation efforts. And by sort of bringing 4 lines in your build scripts, we think we've sort of unlocked the sort of push button machine learning aspect for teams out there, right? So for those who are technical and want to see more details, you can go to docs.launchable.com, and we have more details capturing how you can do this. And for those who want to just talk about it, I'll just remind you to sort of head to launchableinc.com/community and just jump on Discord, and you can ask questions to us there. And for those who are curious on, like, okay, this seems really magical, this seems like a black box, get me behind the scenes. Let's get through that. So one of the key things that we really sort of focus on is this notion of test feedback delay. And the idea is really, really simple. And we were very surprised to see that nobody was, looking at it from that angle. It is the idea of like, okay, I as a developer, push some changes in and the tests are supposed to run and then the tests start. And from that point on to the first failure, how long does it take, right? Because in some respects, as developers, we are waiting for that first failure that gives us the appropriate signal that something's gone wrong, right? So that's sort of the test feedback delay that we care about. And we are focused on reducing it, right? And so the way we started thinking about reducing it is if you think about all your tests, tests, maybe your test suite today, right? Envision that it has a bunch of tests, right? In this case, there are 8 tests. And when some changes come in, right, there is a probability, every test has a probability of failure based on those changes that are coming in. So let's say T8 out here has the highest probability of failure, followed by T4. Now, today, when they get run in these orders. And let's just assume each of these tests take maybe somewhere between, maybe 10 minutes each. So we are looking at T8 to be run at minute 80, right? Where we come in is we said, like, how about we actually start figuring out whether we can, score that probability of failure. And if we are able to do that, we can come in and actually first thing we can do is reorder those tests, right? And so that T8 test can perhaps be run right away, right? So instead of minute 80, it starts at minute 0. And because our test runs are 10 minutes, so somewhere along 0 to 10 minutes, something fails. And as a developer, I found that signal. I didn't have to take a coffee break, didn't have to go to a meeting, didn't have to context switch, and I can continue working. And in this scenario that I'm showing, the rest of the test can continue running, and I'll get like the comprehensive picture at the end of the entire test run on what's happened. But I've significantly sped up my dev cycles. Once you do that, you actually get to a very interesting scenario. And I'll talk about this scenario more in a sort of example workflow. But you can now put a box around these tests, right? And one box can be, this box typically is showing a confidence box. So give me sort of all the tests that are likely to fail that are medium or high, right? And that's the confidence box that we put together here. Another box could be, give me all the tests. I have 10 minutes to run. Give me all the tests that are the most pertinent based on the changes that are coming in that can be run in this 10 minutes. And you can get that box, right? And that sort of unlocks a few behaviors. And I'll talk about that in a subsequent slide. Now, because of sort of this machine learning approach that we've taken, what ends up happening is we can actually sort of come in and look at any part of the testing, stages, right? So we can come in and look at optimizing maybe unit tests or UI tests with Selenium. That's where a lot of time is being spent by developers, or integration tests or acceptance tests. It doesn't quite matter, right? The other beauty of sort of using this approach has been that we can actually support a wide array of technologies, right? So at the outset, like some of this work, you can see unicorn companies like are doing it, right? So in the case, there's a really nice paper by Shopify where they're actually analyzing the source code and doing it. But that approach becomes very language specific. And our approach has been more in lines inspired by what Facebook engineering team has done, where because they use machine learning, their sort of testing tech was language agnostic, right? So today we have like customers / prospects who are on these languages, right? And the sort of some of our DNA from Jenkins, specifically our extensibility DNA from Jenkins, shows through. So we've been sort of working with clients and customers to build an extensible sort of tech stack that can easily plug into any sort of testing language, any testing framework out there, right? And so that's sort of what we've done. And because of that extensibility DNA, if you have like your own custom test runner, it's fairly easy to extend that and work with us, right? So you'll get some more information on sort of docs.launchable.com/integrations page if you want to get into the details of what integrations into each of these environments mean. Right? So that's sort of like, the point about it cuts across a number of stages, languages, but how does this test integration work? Now, I alluded to this in the CLI command page, but at the heart of it, it's very simple, right? You're about to run your builds, you build some, and then you're about to run your test. And the test runner runs the test in whatever order it wants to. In this case, with the CLI integration, it calls on to the Launchable SaaS service and says, hey, here's the snapshot of changes. And here's the, tell me what test to run, right? And the SaaS service comes back and says, run these tests in these orders, right? And then the test runner can continue running these tests in that order, right? And then ultimately it sends the results back to us. The key thing to call out here is that the test runner itself and your build and testing is actually happening on your environment. So it's not running on Launchable, right? So all we do is we are an API call away that analyzes and tells you what to do, right? So we are the intelligence sort of backing your system. So, so that also means that you're not actually looking at sort of migrating harnesses or looking at those kinds of things. Right? So typically one of the questions that come to us is like, what's being sent to you, what's being sent to Launchable, and how sensitive is that data? So the way to sort of think about that is there's some metadata about these code changes that's being sent to us. So specifically, there's a git commit graph that's being sent to us, and that has components such as what are the files that have changed and the number of lines changed and so on and so forth. The source code contents themselves are not shipped to us because we don't quite require them, right? There's no other sensitive customer data that's sent over to us. So for example, we get these questions like, are you looking at the build logs because we are spitting out some sensitive information in there? And the answer is not quite. We don't need to look at that, right? What was amazing for us as we were building the solution was to say, like, even with that level of primitive data on files changed, who's made these changes, that metadata, we are able to come in and make an impact, right? So once sort of this data is sent over, and let's just get a level deeper on like, how does the machine learning model itself work, right? So the first thing is what we feed into this machine learning model, right? So we come in and we take that data that's sent over, right? We process this into this delta, and we look at what the test behavior changes, right? So the delta was something that I alluded to in the previous slide, is like what files have changed, how actively are these being touched, who's sort of making these commit changes, how actively are those being made, is this file often touched? So these are the kinds of things you would intuitively think matter when you push changes in to figure out like, what parts of your subsystem should you be testing, right? And the second thing that we look at is, test behavior changes. This test was passing in the past, now it has flipped to fail, or it was failing in the past, it's passed, flipped to pass. And so we sort of look at those, and we ask the model to produce this correlation, right? So the correlation that the model produces is this, like, given these tests of changes, please predict the probability of this test behavior change. Is that going to flip, the signal going to flip from 1 to 0 or 0 to 1, right? And then we start using some additional information to actually help get the model better, right? So some of the other factors might be duration. So if two tests have the same probability of failure, and one takes 2 minutes while the other takes 2 hours, better to run the 2-minute test first so that the signal comes to the developer earlier, right? Or the model starts learning about ordering constraints, right? In some tests require some others to be run first, so don't change the order, right? So those are the kinds of things that the model learns about, right? And then um, yeah, so I think I've talked to most of the slide, but once we find this correlation of the data, right, um, we say that the model is trained, right? The way I tend to sort of explain this to people is they're often looking at like, how is the model making that decision underneath it? And in some respects, that's a black box. And it's a black box because you don't quite need to know what those intuitions are, as long as you can prove that those intuitions are correct, right? Like if you sort of, the way I think about it is like, as humans, we are pretty good at finding patterns, right? And we look at, well, the security code has changed, so then let's run the security test. And in the past, maybe that has had an impact on performance, so let's run the performance test, right? And these patterns are learned by us and are sitting in our heads. Uh, and it's something similar what the machine learning algorithm does there, right? But the key question is then, how do we evaluate the efficacy of the model? So for those who have sort of taken not taken some machine learning sort of 101 courses, what tends to happen is you look at your data, and you split it into like data that you want to train the model on, and the data that you would evaluate the model on. So once the model is sort of trained, you throw that model the data that you want to test against and see how good you are, right? So the way it looks sort of intuitively here is like, let's say the model's turn, train. And in this case, we will sort of let the model sort the set of tests in the order that it prefers or it predicts, right? And this is for one particular test session, right? And then your test ran, and then the test results came back to us, and the test results look like this, right? In this case, the first 4 tests have passed, right? And the 5th test is what has failed, right? And so on. So if we were truly magical, like, we would have made sure that the 5th test actually got prioritized right up, right? So what's happened is the first 4 tests have passed. We perhaps didn't quite get that right, and the 5th test failing is a signal that we care about, right? Now, if you sort of stack multiple and hundreds of these test sessions, one row over another, you start getting this picture that starts painting a picture of like the efficacy of this model, right? So on the top, let's start at the bottom. We got, you in this particular test session, we ran things and the first test failed. So we got really lucky there, or we were like really good and we predicted that. And if you go to the topmost row, we ran through like 80% of the tests before, or 70% of the tests before the first failure was found. So we didn't quite do this well. So if you line all these sort of red points up, you kind of get to something what we call this confidence curve, right? And what that confidence curve actually ends up telling you is, on the x-axis is the time it takes you to run these tests. So this is a cumulative graph now. And on the y-axis, it tells you the confidence of the tests, or how quickly were these regressions found, right? So in this case, the data is coming from a customer that we help. You see that on the red line, which is the baseline, in their case, it took about 70% test to get to the place where you get 90% confidence that you found issues, right? That's fairly intuitive, right? That's what happens when you have things like running in some sort of random order, right? And in this world, what the blue line tells us, the machine learning algorithm came in and it could get to the same 90% confidence by getting to 20% test, right? And perhaps the 20% test is not the most important piece here. The most important piece here is that you actually have a dial that you can adjust and say like, I can make a trade-off. I could choose maybe 10% of the test and get to like 87% confidence, or I can choose like 40% test to get to 95% confidence, and sort of trade that and make that decision in your dev cycle, right? So the key way to think about this is like, it's almost like, condensing the orange and like really getting a good orange juice out of it. Like, we've got the best signal out, and we are, getting the best pieces out earlier, right? So that's sort of what happens underneath the system, right? Uh, the next sort of a couple of slides are like, I wanted to help you visualize like how and where this actually can come in, right? So I've talked to this earlier, and I flagged this and said I'll come back to this later. But now that you have this system that can predict, what tests can run and which order, and you can get to like 90% confidence with like 10% tests, you can start doing some interesting things. So one example here is where people are talking to us is the pre-merge scenario. We're talking to one company that has a 30-minute, 20-minute unit test cycle, and it seems like fairly small, but they're really, they really think that's fairly long, and they want to reduce the unit test cycle to 5 minutes, right? And so what this scenario is explaining is you have like these pre-merge cycles, or you have like a small C application that doesn't quite have a very, a huge amount of tests, the test run times, right? So in this case, it's taking 45 minutes to run these tests. And when the developer pushes changes in, the feedback came to the developer at minute 22, right? The fact that this is being run by multiple developers during their dev cycles multiple times a day, cumulatively, if you were the engineering manager, you're thinking this adds up, right? And in this case, it's about 78 hours a week. And that's what, 2% days a week that's being spent by his team not working on stuff, right? It's just waiting on that feedback to come in. And in that worldview, just sort of us coming in and reordering tests will have a dramatic impact, right? So my unit tests continue running, right? And they've been reordered, and the feedback now comes, instead of 20 minutes, 22 minutes, at 8-minute time frame, right? And the test can continue running. So like, as I start debugging stuff, the rest of the test failures can come back to me, and I can see what else changed. So I got all those signals in my pre-merge, and I can fix all of them and kind of go through that cycle again, right? So that's one really clear use case that we are seeing, right? So the second workflow that we are seeing is around these heavy integration tests, right? Or acceptance tests or Selenium tests. That's the scenario, right? And in this case, the example here is takes this team 5 hours to run these tests. And what typically happens is, because the tests are heavy, as the tests get more and more heavy and more tests are added, they get run more and more infrequently because the cost of running them is so high, right? And in that worldview, the real way to think about it is what you've just done is you're pushing the risk to your code base, the risk of landing bad stuff to your customer, right? So instead of actually testing the things that could impact your customers right away, you push them on these nightly tests, or you push them on these weekly tests or whatnot, and developers have lost context, right? By the time they find the failure and they start figuring out what's gone wrong. So each of these cycles adds up. So in this case, it's nightly, push changes in. It took like 16 hours for the first failure to happen. And so I come back tomorrow morning and I saw that, things failed, right? And so if you were that engineering manager, you're looking at it and say like 5, maybe developers, or like whatever, like 50 developers have pushed changes in. And in the weekly wait time now is 1,000 hours, right? The people have pushed changes in. They're not really waiting on things, but they have moved away from the most high priority item, and perhaps they're in meetings or doing something else, right? So in that worldview, the adaptive subset, which was, let's put a box around this, kind of really makes sense. So in this case, what I'm showing here is that the T line is maybe 30-minute adaptive subsets that run throughout the day. And this box is time boxed, right? Not confidence boxed, right? So now as a developer, when I push changes in, Launchable comes back for this adaptive subset run and says like, look, in the last 10 minutes, Harry pushed in these changes, Drew pushed in another set of changes, and the next adaptive subset is about to run now. So based on these two changes, let's run these tests, right? So you've essentially moved the nightly integration test as part of your dev cycle. So you've shifted tests left without actually having to rewrite the harness, rewriting the test, or re-architecting anything, right? And when that 30-minute test runs and something fails, I got that feedback right away and I push those changes in, right? I can fix that and can keep doing this. And my sort of dev cycle is now reduced from days to sort of hours, right? So those are like the two key workflows that are happening. So I'd like you to sort of, if you think this is interesting, I'd like you to sort of think about like the various phases in your organization, your testing cycles, and sort of come to a place where like, are these like, do any of these workflows sort of impact your dev cycle and where we can help? So one question that keeps coming up is like, wait, looks to me like you're telling me that we shouldn't be testing anymore, and I'm in the QA organization, and I just can't actually go and tell my manager that, oh, that thing escaped because we stopped testing because Launchable said so. And the answer to that is we are not actually saying that, right? The real key thing is the way I envision this is we ask people to actually put a fence around the farm to make sure that no stragglers break through the fence, right? And so the way to think about it is we are asking you to move shifts, test left, test earlier, reduce risk, and still, maybe have like a nightly run, or like, in the case of a unit test scenario, right? We come to the conclusion that this team says we need to reduce cycles from 30 minutes to 5 minutes. So let's run 5-minute tests and then let all developers push changes in and introduce a new sort of testing step, which comes in post-merge that can test everything, right? Test all the unit tests. So what you've just done is you've really unlocked developers to go rapidly, like 5-minute dev cycles, and maybe once an hour or once a day, you're running all the unit tests, right? And so you've moved some tests right to actually go faster. Another with the integration tests, right? You still perhaps run the nightly test, right? And when you run the nightly test, you still capture some of the stragglers that weren't captured through these 30-minute test runs through the day. So that's sort of the worldview you end up with. So I've talked about technology, I've talked about the approach. Let's just talk about very quickly on like what are the impacts that we are actually talking about with people, right? So here's a sort of Silicon Valley company. You would typically think of these companies as this one as a unicorn company. And the key sort of reasons why I'm bringing this is to show like this approach actually works with these kinds of unicorn companies. So in this case, you have the business side really keyed in on developer productivity and employee satisfaction, while the technical side leaders are focused on the feedback delay that's coming to them, testing bandwidth. In their case, they have like 3-day test runs. So QA triaging is a real big challenge. So they were like, honed in on that. So in that worldview, what ends up happening is in their world, like developers are pushing changes. They're using Gerrit. They're running unit tests and integration tests. And they were using Bazel to optimize their builds, right? Because their builds are not fast. So that's what I mean by these are unicorn guys that their problem is so severe that they're looking at technologies such as Bazel. So in their case, they're really focused on the pre-merge side of the house. So as we started looking at their data, what we realized is, their worldview looks something like that. I think their team was about 50 people. It takes them multiple patch sets, about 5 patch sets to actually move one change through the system, right? And then it takes them about 6 changes per day. Even with a team of 50 or 60 people, only 5 or 6 changes make it through their day, right? So you can clearly see that they're not being, they are grappling with these productivity challenges, right? And so if you sort of stack them up, these sort of waiting times and so on and so forth range from like, in the high, in the low $1 million range, right? And where we could come in and say like, hey, by bringing us in, like we can, reduce this by 40%, right? And the way we said that is we came in and we looked at and produced that confidence curve that I was talking about earlier, right? And in this case, that confidence curve, we sort of laid out to them and said, like, look, in this particular project for this dev cycle, testing cycle, we are pretty good, right? You could get to 85% confidence just by running 2.5% tests, but like getting to 90% confidence or 10% is not a bad deal either, right? So like that's one of the things that we recommended to them. And in that worldview, what ends up happening is their sort of dev cycle, which today for pre-merge was 51 minutes, right? Gets sort of down to 31 minutes, right? And so your end-to-end dev cycle is reduced by 40%. And I just want to call that out, that within that, about 30 minutes is sort of in a build and compile time that could not be optimized by us, right? So our impact is much higher, right? In the case of, if you just look at testing cycles, our impact is much, much higher than the 40% that we're calling out, right? So if you were like this engineering manager, right, and you were thinking, you brought this in your system, what you're envisioning, and these are some of the next set of slides or something that, are not in the product today, but like we'll get in the near future, is this notion of like, hey, my team in this is waiting 16 hours on an average, cumulatively across my team is waiting 16 hours every week for feedback. And then I push this button with Launchable, and now that starts reducing to 2 hours a week, right? So that's sort of the cumulative impact that engineering managers can start seeing, right? And one of the reasons why we are calling this out is, as engineering, I find like engineering and product, I've been in both worlds. We are pretty bad at making the case on like, investments from the business side of the house on developer productivity improvements. And we're hoping that something like this actually makes that case effectively and arms, technical leaders in the organization to, ask for and demand for, budgets to help things happen, right? But that perhaps is not the key. Like reducing that time is not the key. The key ends up is by reducing that 16-hour time, you are starting to really, push more changes through. So developers, the impact on their developer productivity truly can be measured by the number of changes that they are landing in the system, the number of, finished bits that they're landing in production, and so on and so forth, right? So that's something that I think is a direct impact, and it's a top line impact that happens to an organization, right? Another interesting sort of scenario, just to help you visualize, is if you had that integration test scenario that we were talking about, and you were running adaptive tests, right? And whereas in the past, right, you were looking at this and you were finding most issues in your integration test, right? And this is the green line, right, in your nightly test. But the fact that you brought in an adaptive subset, what you're finding is most of the issues are being found by the adaptive subset, and your nightly tests are like sailing through, right? And so what happens is when those nightly tests actually publish the binary to other teams and organizations, that lands at much higher quality, right? And all of this, if you sort of look at this and cumulatively like put them together, well, I'm just putting the bottom line together. If you just save them, the X hours in the organization, and every developer costs like, Y hours per hour, right? Y dollars per hour. you can start seeing like the kinds of savings you can make in the organization. And not even talking about the top line in the organization, right? So the changes that are coming in because you landed stuff to customers much faster at a much higher quality, right? Going back to that, high agility, agility and high quality slide, right? You now have that rocket factory that brings can really deliver at high agility and high quality. So hopefully, I've walked through like a lot of pieces here, but I wanted to give this picture on how easy it is to turn this on, kind of give the underlying motivation of like how we've sort of behind the scenes on how we built this subsystem, how we built this system, and sort of our general inclination on helping, improve quality in an organization and getting developers to move fast. So the last maybe couple of slides, where we are today is we are actually signing up, folks on early access. And the idea here is that we want, people to try the service out. You can sort of, instrument your build scripts, call our platform, get a model train and see the impact in your organization with the hope that when you become a customer, we'll offer you a 25% discount, right? And we'd love to talk to you to understand what's happening in your system and really get feedback on like how well are we doing before we actually go GA later this quarter. Right? So this is a call to action to kind of come back to us. The next things that, if you're really curious on how this actually looks like, because I really talked to slides, Kosuke is actually doing a live demo 2 weeks from now. And you can go to launchableinc.com/webinars and sign up for that. And he'll walk through like a scenario and show how the tech actually works. A lot less slides and much more demos. So that would be more exciting than what I presented today, right? So Launchable Inc./webinars. So where to next? So one, if you have questions, I'll ask you to post your questions in the chat. Drew can read that out to me and I can answer them. We've just started a Discord channel. So you can go to Launchable Inc./community, jump in, /spacebar. We're not going to pitch there. We'd love to talk to you, see, what resonated with, what we're talking about, what didn't, even if it is like the slide deck sucked, could be better this way. I would love to hear that and talk to you. And if you want to partner or request the slide deck, just come on to info@launchableinc.com. And if you care about, deep diving into the, how we do stuff and the CLI, you can head over to docs.launchableinc.com, right? So in summary, the idea for us is to bring push button machine learning to testing to reduce, software dev cycles at reduced risk. Really let organization bring in continuous quality practices, deliver high quality with high agility, right? So with that, I'm going to stop talking. I'll open up for questions.
At the moment, there's nothing in the chat, but I am monitoring the Q&A and chat channel.
All right, thanks. We'll give it a minute more, and while that's happening, I'll sort of think about some of the more commonly asked questions. Some of the questions that we are asked on is like, what data is being sent over? Like, do I need to involve InfoSec within my organization, and how does that look? So a few answers there. So hopefully the slide that I talked about on like what data is sent over helps you sort of understand that we are not shipping code to you're not shipping code to Launchable. Right? That's one. Two, we let our sort of early access customers review the data that's coming and that's about to be sent, so that they understand what's being sent over the wire to us. And so we've sort of talk to like both small and big organizations with big infosec departments, and we seem to do very well through those conversations just because we're not sending something risky over. But if you go to Launchable Inc. / how it works, you'll see sort of the kind of data that's being sent over to answer that question.
Hey, Harpreet, we do have a question in the chat. Ben asked, how much setup, data, hours, etc., is required before I can see value?
Great question, actually. So the idea is somewhat, the answer is somewhat fuzzy, right? It really depends on the frequency of the tests that are being run, right? So really, it's like if you're running, say, a few, maybe once a week, that's or once a month, we've had somebody come into us with that. They'll see the model will take longer to train than say something that's being run multiple times a day, right? So the answer sort of it really depends. So that's one. And two, somewhat more specific with some of the early access customers and prospects that we've talked to, we see the training time between like a couple of weeks to maybe a few weeks, right? So so it doesn't take 3 months to do this. It takes anywhere, to me, it's like 2 weeks to 4 weeks. That's sort of the range that I have in mind. One thing that we are actually actively thinking through and is like what we found the state of the art, right? Even with the order today, like the random order, um, is so low that we can actually just come in, and we're thinking of just coming in and making even very simple predictions, such as just reorder, based on the perhaps the duration of the test, right? To start with, and that should start showing you the impact right away. And then what the way to think about it is over the next week or two, the model will keep getting better and better and better and better, and so on and so forth. So that's sort of the world where sort of our heads are at the moment.
Okay, no other questions at this time.
All right, so I'll call this webinar to a close. Thank you very much for joining, and thank you for staying on. Love to see you either on the Discord channel or through an email, or hopefully talk to you sometime. Thanks.